Thank you, thank you, thank you. Had a comment in the comment section of a video about doing thermal power plant preservation and decommissioning. So that's what we're going to do today. We're going to provide some content that was requested. So let's get into it. We're actually it's a good timely topic because there's a lot of plants that are either being decommissioned or preserved right now. So we want to talk about how that goes, and we'll just jump into it. So I'm going to talk about some real world case studies, some examples that I've lived through. And I think that's the best part of this channel, is that I'm not just giving you what someone else's experience was or what the book says. I'll take you through what my experiences have been. So real world examples of preserved equipment, demolished equipment. We'll talk about a fossil plant demolition. A few, actually. We'll talk about combined cycle power plant. Now this one was pretty nice. It had been about 60% complete during construction, and then they mothballed it because of regulatory changes that we'll talk about later. But at that point, at 60%, they just maintained it, preserving it. Later, I was part of the project that reactivated it, so I'll tell you some lessons learned that come from reactivating large gas turbines, large combined cycle gas turbines. Small gas turbines, we see this where they get preserved and then several years later they're sold to another utility. This can, work out for both parties because the seller holds on to the equipment without just taking scrap value and taking whatever the salvage yards give them. And then, the new buyer gets what they needed without paying full price for a brand new gas turbine. I was involved with a fossil plant that had a boiler that burned fossil fuels, and the steam turbines would make electricity. Now it was being converted to use all the electricity inside the fence for crypto mining. One fossil plant that I was involved with was mothballed. It hadn't been demolished yet. It was in the middle of downtown Baltimore, so it was going to be a difficult demolition job, and it was taking a while to get it done. And so the movie industry decided they wanted to use the power plant for their set. So the movie 12 Monkeys was shot there. You might see a business card in one of the scenes or two. Alrighty. So in a coal power plant demolition, this is what we're going to look at. Here's the equipment. This is the before, and this is a very small coal power plant, just so you get an idea. But you can take a second here and look at where there's a unit 1 and a unit 2. There's boilers. You can see 2 steam turbines there, and each of them have their own generators. And you can see one of the GSUs. There's the other GSUs just at the bottom of the screen, and then you can see cooling towers. So that's what it looks like before. This is what it looks like in the middle of the process of decommissioning it. So you have to be really careful when you're doing this, obviously. So let's go through what the process is. It takes a few years to do this. You don't just roll in with bulldozers and dynamite and start knocking down these plants. The first thing you have to do is remove the combustible material and the hazardous materials. That's not as hard as it sounds. It just takes time. You have to remove all the oils, the lubricating oils. You have fuels that have to be purged out of piping. You have potential plastics in cable trays. You have battery rooms that are full of plastic. So there's numerous hazards that have to be removed before we can take the fire protection systems out. Now the catch-22 a lot of times is that the fire protection systems need electricity. The detection systems do, the actuation devices on some of the protection do. So, what are you going to do when you need to remove the transformers that are providing the power for the fire protection system? That's kind of that chicken and the egg situation, and you keep the fire protection and services as long as you can. When it's the only need for the electrical, you can pull it out, and then you can pull the electrical out. These projects are going to be massive. You're not going to hide them from the public, and you're not going to be able to build a total wall around the facility to keep all your dust in. A good start is a very tall fence that will keep the ground level dust to a minimum, and signs for the public to report when dust is getting off-site so that you're made aware of it, not your regulators. You know, you would rather your customers tell you that you have a problem rather than your regulators telling you have a problem. So be very careful. We're going to have to sort all this material and get the hazardous material out of it. You know, it's easy to kind of remove rubber and to remove plastic and to drain oil, but when you start getting asbestos or lead-based paint, and you have hazardous materials that are just part of the debris, you're gonna have to be very careful about not spreading that contamination. Give you an example. You can play I Spy with my little eye there and try and figure out what all these pieces and parts are, but you can sort of see now that there's some sorting going on already. There's this, believe it or not, is some organized chaos. All right, something else you're gonna have to work, you know, there are gonna be a lot of cranes involved moving all this debris. They have to be very careful that they don't put their boom up into a power line. It has happened, and you have to be vigilant. You have to train the operators to be very careful about working around these energized lines. All right, now let's go from demolition or decommissioning into preservation. So we don't always just tear down the power plants. Sometimes they're preserved for a while, sometimes they're preserved and then reactivated. So let's talk about why would you want to preserve a plant and just leave it there idle? Because it's going to cost you money to maintain it safely in that configuration. You're going to have to keep the transformers dry by keeping them warm and backfed. You're going to have to keep, you know, the gas turbine equipment ventilated. You're going to have to keep a lot of electrical systems running the meter, costing you money to keep this plant idled. So you might do that if there are changes in the energy demand that are fluctuating, and that might go back and forth just based on political winds. If there's more renewable energy coming into your area, that might be a reason that you would idle a plant and not totally decommission it, because the renewables aren't a one-for-one swap with an existing baseload power plant. So yeah, you're going to take a little time to make sure that those renewables are going to serve the need of the community before you demolish a baseload power plant. You could have regulatory requirements that are forcing you to idle it and not demolish it. So what else? Why would you? What are the results if you do preserve it? So this is, you know, we go from why do you want to do it to what do you get for doing it, and you know, you're going to have flexibility for future operations, right? We just talked about that. That you can reactivate the plant. You can maintain the value of the plant, because as we can see in some of these examples, they get sold, especially the smaller gas turbines, and then finally you can prevent the deterioration of that. Now, we're risk engineers and we're learning to be risk engineers, so let's talk about what are the risks that are involved with thermal power plant preservation and decommissioning. The biggest risk is the presence of moisture. Yep, that's going to do it. So we want to do everything we can to keep the moisture out. The next biggest risk, vibration from external movements. Either other equipment hits them during or it gets damaged during shipping or movement. So you just have a lot of heavy equipment and heavy loads being lifted during this period. So a lot of things are falling, and there's a lot of vibration that this stationary equipment doesn't normally see. So you basically have many earthquakes going on every day. And then the last one is foreign contaminants. We want to make sure we keep everything out, not just the moisture. So let's talk about a gas turbine preservation. This is not the best way to do it. This is not, to be fair, this is not a preserved turbine. This is a turbine that's being repaired during after an event. But just to see the cleanliness standards that, you know, we can't judge what's going on here, but if you were out looking for anything that could cause a problem as far as cleanliness, you'd see possibly that tape right there and the gloves further over there. So you don't want to have loose objects laying around that can get into a gas turbine. That's so critical. All right, the parts and pieces that you're going to use, you need to have an organization system, and you know, be fair up front with this. This is a stator row 3 box, so it's the whole row of stator blades, and vanes, they are all numbered and organized. You can see the inspector going through these. He's looking for damage, but the same process to identify and categorize all your equipment if you're going to preserve this equipment. All right, so now what do we want to do? We got to keep it clean and dry. We have to protect it from corrosion. And then we want to regularly inspect it to make sure that everything's working the way it's supposed to. We can't just throw some desiccant in there, wrap it up, and leave it for 5 years and expect it to look the way it did when we left it. These are a couple of links that I'll leave there that you hopefully can cut and paste in some way, but they're going to help you to see some of the content that's about to come up. It might be too small for your phones if you're watching on your phone, but also a place to go in and get a little more detail on what I'm about to talk about. So in a thermal power plant decommissioning, what we're going to have to do, we have to lay up all of the systems. And just to kind of give you an idea, you can look and see fuel systems, boiler systems, water and gas, right? The steam turbine, you've got the steam side, you've got the oil system side, and you have to worry about periodic rotation of the rotors. When you have those big steam turbines, you don't want the rotors to bow. You have to rotate them to keep that bow moving. Generators, condensers, feed water systems, cooling water. I don't want to read it all to you. These are just a quick rundown of the systems in a thermal power plant that you're going to have to lay up. So the next step, we have to control the humidity during the preservation process. So what I've seen is everything from tarps and fans to tarps with powdered desiccant or granular desiccant. I've seen little emblems or little targets on the outside of the plastic containment that quickly tell you whether the inside is full of humidity or not. They're just humidity indicators that quickly tell you by looking at the color if you've got some sort of over humidity going on inside. Alrighty, so again, desiccant humidifiers, the important thing is that we also follow up. So we're going to have checklists that help us go out and remember what to look for when we get out there, because it's not all the normal stuff that we look for while it's operating. Now we're going to look for the equipment. We're going to look for moisture getting into the equipment rather than something coming out of the equipment all the time. We're going to test all the equipment that is necessary to alert us that, say, the fans that provide the ventilation have an alarm when they stop running. We have to test to make sure that that's going to work. And hopefully nobody's out there eating silicone gel, all right? So here we go. We're going to get through several slides that will go through actually how to decommission and preserve certain equipment in the plants, in thermal power plants. So centrifugal and rotary pumps, you can see these are some of the steps. Starts with flushing and neutralization, filling it with oil, kind of preventing rust, that kind of thing. You'll see as we go through these various pieces of equipment, this is going to be reciprocating pumps, that occasionally there'll be references to something called product 1 or product 2, product 3. These products are listed in those articles that I provided, so you can go back and take a look at what they're suggesting. I think there's a concern for free advertising and whatnot, but this is how to lay up turbines, large fans. Okay, you can see all these pretty much start with cleaning it, drying it, oiling it, and then coming back and keeping an eye on it. Okay, large motors, centrifugal process compressors. You're starting to see, some of the same sort of basic steps. Lube oil system. Okay, again, we're going to follow these steps for your lube oil system. Guys, these are out there for you to look at on the other websites. I kind of did some of the work getting them here for you, but you can go back and take a look at each one of those at how to preserve the various systems in the thermal power plants. Now, when it comes to reactivating the plants, this is very interesting. I was involved with reactivating a 501G, very large Siemens gas turbine with steam turbines. It was a combined cycle plant. And this is what happened. The plant got to 60% complete, then it got mothballed, and then a few years later, they decided to reactivate it. Well, was it still 60% complete? Not anymore. First off, during those few years, the parts were cannibalized out of this unit for the rest of the fleet, right? This is a gas turbine, and gas turbine parts are very expensive. Sometimes they're not even made yet, and you have to wait for them to be made. So if you can find somebody else's that you can use, you're going to go get them if you can. So this plant had a lot of cannibalization. The next thing, is it really 60% complete when you have to go in and unbuild it? Yeah, if you preserve or idle a plant, no matter how good you do it, especially where you've got humidity, you're going to have to disassemble some of it in order to inspect it. So you're going to have to take a motor that was installed, tested, and it ran fine 3 years ago. Now you have to disassemble it, blank off where it's connected to, disconnect the electrical, send it to a shop, have the motor itself checked to see if it's moist inside, see if there's any corrosion, see if it works, see if it measures and all the insulation works. So then you have to send it back to the plant and install it again. That's if nothing was wrong with it. If there was something wrong, now you got to order a new motor, or you have to rewind that one. That's going to take time. So just the process of uncovering what the damage is going to take time. And for someone to look in and say, you're 60% complete, you're going to be done in this X number of months, that's very difficult to do. Let me say that you got to be 60% complete, and we've spent at least a month or two taking this plant apart, probably a lot more than that, but at least a couple months to figure out what all needs to be fixed, what all needs to be ordered, so that we can begin putting it back together. So this 60% complete plant really was about 40% complete when it came down to it. So put that in your models when you're looking at what's it going to cost, when's it going to come online, when's it going to start making money. So that's a very important part of the reactivation process. All right. What can you expect to go wrong during the reactivation process? Equipment failures, the regulations can change, market conditions can change. So that's the problem with the whole preservation and reactivation cycle, is that it takes a while to get a plant preserved or decommissioned, and then it takes a while to get it reactivated. So in either case, it's going to be a challenge, and hopefully some of these topics, some of these guidelines help you, or at least point you in the direction where you need to go. If you've never been involved with a decommissioning project, hope you're familiar now with some of the different things you need to think about. With that, let me say thanks. Please subscribe. It helps get the videos out to more people. It won't get you bombarded with a whole lot of videos. I only put out one every now and then. So just please subscribe and come back for the next one. Thanks a lot.